value of each from -3 to 3, and then just added 1 to the value.
Get the value from -3 to 3.
If I did -3, and so I added 1. I mean, -2, then I plus 1, and then the other one, 2 plus 1, and another one, -2 plus 1. Why can't you do that?
I'm not sure where are you adding plus 1?
To each of the, because you know how it's f of x plus 1?
You know how you do the sections? You're just putting the numbers in the section.
Oh, I see what you're saying. You're saying that this is -2 plus 1. No, you can't. You see, the thing is, this area A
Is it only if it's in the x?
represents like -3 to, I don't know, maybe -2-ish. And the total area under the curve from here to here. See, this 1 is supposed to be, you see how f is a function. It's this function. It's all curvy and stuff. 1 is not the same function. It's like a different function. So maybe the way, I think maybe the better way of thinking of this is if you have this dx, we could break this up into 2 integrals, or into 2 of these. So what would that look like? Plus
That's just,
No, I don't think that made it worse. Okay, think about it. Look, you have this. Okay, you have this. F of x is here. So find the area of this plus the area of under the curve of 1 from -3 to 3.
so like, just a horizontal line, right?
Yes, and that's what this one was. So this part would be found by looking at that graph. And this part is found from looking at this graph. Because these are 2 functions. This is f of x, that's just 1. No, what did you just say? Yeah, what does that mean?
It's like a saying.
It's just a saying.
Oh gosh, oh my.
I'll fix it in this since you broke it.
Okay, so here's the thing. This is kind of weird. This graph, what is this graph supposed to represent? It's the temperature, it's changing. So this is a rate. That's why I got confused. This is not, this doesn't represent the, this does not represent the temperature at any given time. So what this is saying, let's trace to 0. See 0? What's it saying? 110. So at t equals 0, I'm getting this number. That that the rate, or I'll just do it. Yeah, r of 0 equals -110. What does that mean? Think about rate. So it's starting to cool off at a rate of 110 degrees. So what all this means is the pizza is cooling at 110 degrees per, and it says what is it, per minute. So it's, at the very beginning, it's changing at 110 degrees per minute. And let's say because we're interested in 5 minutes. At 5 minutes, what does this mean? R of 5.
At 5 minutes, it's a rate of 14.8.
Why do you think that is? So how come it's cooling faster at the beginning than at 5 minutes?
It's already cooled
Because
off
in the
enough.
beginning, like different changes, like 350 to 75. Then they start like getting really close.
Right, the closer you get to room temperature, it's going to just get slowly and slowly, it's going to start to cool off more slowly. So pizza is cooling at about 15 degrees per minute. So that's how things happen. Like for example, when I first get a cup of coffee, it cools off pretty fast. But then it just kind of stays that temperature. It doesn't get too much colder. It takes a long time to reach room temperature, and technically it will never reach room temperature. It'll just get really, really close.
Is it when you put cold water in a hot pan?
No?
Okay, so let's look at this. So what's this asking us? What is the temperature at 5 minutes?
Can we just play it in 5?
I know. T.
Well, we just did. But does this equation give us temperature?
That's true.
Oh no. Trick question.
No, it doesn't. But let's look at this. I'm gonna already tell you this. Okay, no. Let's use the fundamental theorem of calculus. I'm gonna write it down and tell me what all the numbers mean in this context.
5.
Okay? Think about starting points and all that business. Yes, Melissa.
Did I tell you?
Yes.
So F of B, that's the temperature that we're actually looking for. And then F of A, that's going to be I think it's
110.
The starting
Negative 10. Negative
Right, so this is the starting point, 0. And then what's this notation going to look like?
like the change in temperature.
From where to where?
From the start.
Starting 0 up to 5 of
No,
f prime. Now, when we're looking at f prime, that's going to be what equation? It's, well, I wouldn't say original, it's this changing equation. Because, remember f prime, remember how I was telling you, you need to think of it as how something is changing? This tells you how the temperature is changing. Okay? So do I know any of these values already?
Yeah.
What?
You know that F of 0 is 350.
F of 0 is 350. This is the starting temperature. Plus, I need to find the change in temperature from 0 to 5. How can I find that using the calculator?
You do the same thing.
Plug
7
in 0.
What? So, looking at the graph, this tells me how the pizza is cooling off. If I do second trace and find this value from 0 to 5, it's going to give me this. What does all that stuff mean?
That's temperature decreases. 783.
So again, this is the important number of this problem. What is this supposed to represent?
The total
From 0 to 1.
temperature from 0 to 5.
So does that mean the temperature is negative?
It's cooling
it's cooling off, the change is negative, meaning the temperature goes down. So it's not a negative temperature, it's a negative change. So that means f of 5, the temperature of the pizza, is 350 minus 237. 350. So does the fundamental theorem of calculus make more sense with that problem? I hope it does, because that really summarizes it. It's like the total change. This is how you finish. This is time at 5 minutes. Or the temperature at 5 minutes is the temperature at 0 minutes, 350, plus any change that happened in the first 5 minutes. So it cooled off by 237.783 degrees. So to finish up the answer.
Bring your